Okay, functions f is true for x is greater than or equal to 0. G of x is true for all values of x, and a is positive. Given that it's okay, so first thing I need to do, I need to find out what f of e to the 4 minus 3 is. And that means instead of writing x in here, this expression, I just write e to the 4 minus 3. So that will equal 2 plus ln of, not x, remember, e to the 4 minus 3. And then I've got to put plus that 3. So that equals 2 plus ln minus 3, that'll be ln e to the 4, which equals ln and e on inverse operations, so they cancel each other out. So that goes to 2 plus 4, which equals 6. So now I just have to know that g of 6 equals 9. So that means I put in 6 into here. So I might as well write that down. G of 6 equals 9. And put in 6 into here. So that will give me a times by 6 squared equals 9. So a equals 9 over 36, which equals 1/4. So that does the first part. Find an expression for the inverse of x. Okay, for doing this, I'm going to put y as being that. So y equals 2 plus ln of x plus 3. And then I'm just going to undo everything until I get x equals, and there we are. So first thing I'll do is take away 2. I'm going to get ln of x plus 3 equals y minus 2. Get rid of the ln, so I'm going to e it. And that'll give me x plus 3 equals e to the y minus 2. And then take away 3, so x equals e to the y minus 2 minus 3. And therefore, the inverse, write properly, the f to minus 1, the inverse of x equals e to the x minus 2 minus 3, because we don't want a y in it, because it's a function in terms of x. So that's what it is. And we've got to work out what the the domain of the inverse. Well, the domain of this bit is x is greater than 0. So the range of this one, x could be equal to 0. So you get 2 plus ln 3. And therefore, the domain of the inverse is greater than or equal to, because it could be that, 2 plus ln 3 for when x is 0 at that particular. It's going to be greater than or equal to that. And then part 3, given that this, find the value of n. So this is, let's put it right down into the expression question, f of that's normally e to the capital N minus 3 equals ln of 53e squared. I'll try and remember the brackets and I often forget them. So this is f of, and I put in e to the n minus 3 into f, and that will give me 2 plus ln of e to the n minus 3, and then plus that 3. And that equals ln of 53e squared. Simplify this, that gives me f of 2 plus, that's going to be ln of e to the n, so it's going to be 2 plus n. Because ln and e will cancel each other out. And that equals ln of 53e squared. Put in 2 plus n into this bit, and that will give me 2 plus ln of 2 plus n plus that 3, and that's got to equal ln of 53e squared. Now at this stage I've got one unknown here, n, so I just have to keep on undoing things. First thing I'm going to do is take away 2 from both sides. So I'll go ln, I'll tidy these up a bit at the same time, 5 plus n equals ln of 53e squared minus 2. I'm going to have to get rid of this ln, so I'm going to e it, and that'll give me 5 plus n equals e to the ln 53e squared minus 2, and then n equals e to the ln of 53e squared minus 2, take away 5. Okay, this bit here, so n equals e to the ln 53e squared, and then times by e to the minus 2, because we got the index here, we got subtracted, and so if we have that in minus 2, if we add these two indices because they're multiplied together, that will give us that. So take away that 5, so n equals e to the ln 53e squared will be just e and ln cancel out, so that'll be 53e squared times by e to the minus 2, so that's times by 1 over e squared, and then take away that 5 at the end, so that way n equals, e squares cancel out, 53 minus 5, and so n equals 48, which is what I wanted. I think probably the hardest bit there is going from this bit to here. Then we've got power times the power, we add the indices, so if the indices are like this, then that's going to have to be, one will be ln of 53e squared, and the other one will be minus 2. You could have think of it as divide, but that's what this is here. Hopefully that's clear, and that's 8 done.